The next thing I want to talk to you about, with the assistance of Grumpy Cat over the side here, is the distinction between descriptives and inferential statistics. So I know this is a lot of words here, but all of this stuff is really important just to get the fundamentals so that you can learn some more stuff later on, the more complicated stuff later on. So you absolutely have my permission at any time to stop and to get a coffee or a tea or anything that you want, really, to help you get through the rest of this lecture. We're on the home stretch. All right, descriptive stats. Descriptive statistics are ways of describing or summarizing or aggregating the sample that you've collected. So when you collect data from a sample and you get information on a bunch of variables, variables being things that you've got information about, descriptive statistics allow you to summarize that particular data that you've obtained from the sample. So descriptive stats apply to the sample only. Inferential statistics and the process of using inferential statistics to answer research questions is the idea that what you've learnt from the sample, the information that you've obtained from the sample, you can then make generalizations or inferences back to a wider population. So remember I said before that research questions always apply to a population. Data is obtained from a sample, but the conclusions that you make from the data obtained from the sample always go back to the population. And the process of making generalizations or conclusions or inferences from a sample back to a wider population, that's the process of inferential statistics. And because that's the process that we undergo, the fact that the sample is representative of our population is really, really important. Our sample has to be representative of our population. It has to have the same kinds of characteristics as the population in order for these inferences or these generalizations that we make to be appropriate, to be in any way valid. Okay, next thing, different kinds of hypotheses. So in a couple weeks' time, we're going to be talking a lot about hypothesis testing and the process of hypothesis testing. So this is just to kind of whet your appetite a little bit, or just to get your head into it so that it's not too much of a shock for you when we talk about this stuff in week 5. So the first kind of hypothesis, there's 3 different kinds of hypotheses that I'm going to be talking to you about. The first kind is a research hypothesis, and you'll already be familiar with this kind of hypothesis. When you read a research study, at the end of the introduction, that paper usually states a research hypothesis. And a research hypothesis comes from the research question, and it's that prediction about what you think is going to happen in the world. So I predict that psychotherapy is going to be more effective for people with depression than drug therapy. I predict that people who get an early intervention for mental health will have more successful outcomes compared to people who get late interventions. I predict that the more students enjoy stats memes, the better they'll do on their final 105 grade. That's your research hypothesis. That's the prediction that you're making about something that you think is true, but that you don't actually know if it's true yet or not. That's the process of doing research. The next 2 kinds of hypotheses are statistical hypotheses, and these aren't as relevant for the research process as the research hypothesis is, but they're fundamental to the process of statistical inference and statistical analyses, and that's why they're really important for us to talk about. So we have 2 different kinds of statistical hypotheses. There's a null hypothesis and an alternate hypothesis. The alternate hypothesis is the opposite of the null hypothesis, and the null hypothesis says that there is no difference between groups, there's no relationship between variables, there's no change in anything over time, there's nothing going on, there's no effect. The word null in the null hypothesis means nothing, nada, there's nothing going on. And the null hypothesis is always saying that there's nothing going on, even though the form or the particular expression of the null hypothesis will change depending on what statistical tests we're actually talking about. On the other hand, the alternate hypothesis is the opposite of that. So it's saying that there is some difference between the groups. There is some relationship between variables. There is some change over time. There's something going on. So as you can see, they're both very broad hypotheses, and the reason for that ties into the process of statistical testing, which we'll talk about in week 5. But they're the opposite of one another, and between the 2 of them, they cover all possible bases. So either there is a difference between people who experience psychotherapy versus antidepressant therapy on depression, or there isn't. Either there is a relationship between how many PAL sessions you attend in your final grade, or there isn't. There's either something going on or nothing going on. There's either some difference between the groups or no difference between the groups. And both of these types of hypotheses are really important for statistical analyses. Why that is, we'll talk about in week 5, but just take my word for it at the moment that they're both really fundamental to the process of statistical testing. So to give you an example here, let's say that our research hypothesis in our example with 105 PAL attendance in your final grade, our research hypothesis is going to be that the more PAL sessions that a student attends, the better their final 105 grade is going to be. That's the research hypothesis. That's the prediction that we're making that comes from our research question. We could then have a null hypothesis, and the null hypothesis is saying that there's no relationship between PAL attendance and 105 grades. So the null hypothesis says there's no relationship, there's no effect of PAL attendance on 105 grade. The alternate hypothesis, on the other hand, says that there is a relationship between PAL attendance and 105 grade. It doesn't necessarily say what that relationship is, but it says that there is some relationship between PAL attendance and 105 grade. It's something other than no relationship. Alrighty. So the next thing I just wanted to talk about was, again, to kind of set you up for the process of inferential statistics, which we'll be talking in more detail about in week 5, which is hopefully a way of trying to understand this process of inference, this idea of collecting information about from a sample, but then making a generalization back to a wider population. So in an ideal world, once we had a research question, once we had a specific hypothesis about something that we think was going to happen, a research hypothesis, because that research question is about the whole population, in an ideal world, what we would do would be to collect information, collect data from that whole population, to ask everybody in that population questions, to measure stuff about all those people, and so to get data from everybody in that population. But we really can't do that. And the reason we can't do that is just because it's not feasible, it's not possible most of the time. So if I'm interested in every single person in Australia who has depression, I can't actually physically measure stuff from every single person in Australia who has depression. It's just not feasible, it's not possible to do that. That would be the ideal, but unfortunately we can't do that. So given we can't do that, the next thing that we could do would be to run this particular study, this particular research project that we've designed to address our research question multiple times to see what the average effect is, to see what the average result is. So I would gather, say, 100 people at a time with depression and randomly allocate half of them to a psychotherapy group, half of them to an antidepressant group, and measure the effect of the therapy on their depression. And I would do that a bunch of different times to be able to aggregate or to summarize across all those people what the average effect is. And the reason that we would do it multiple times is because people vary, is because some people are more depressed, other people are less depressed. Some people might take more to psychotherapy, other people might take more to antidepressant therapy. Because of that variation between people, that's why we need to kind of aggregate and summarize across people to see what the average effect is or what the average relationship is. So in an ideal world, if we can't sample the whole population, what we would do would be to run our particular study multiple times, the same study over and over again, replicate the study in order to see what the average effect is, what the average result is. But again, it's really not feasible for us to do that a lot of the time, or most of the time really. It would just take too many resources or too much time and effort to do that kind of thing. So because we can't do both of those or either of those things, the thing that we use instead to kind of approximate that process, that second process of replicating our study, running it multiple times to get an average effect, is to use what we call inferential statistics to be able to see how likely it is that any effect that we can see in a sample is reflecting a real effect in the population. So the process of inferential statistics uses inference, uses probability, to see what the chance is, what the likelihood is, what the probability is that the effect that we can see in the sample is reflecting a real effect in the population. We don't know what's happening in the population. We use the sample to approximate the population, and we can use inferential statistics to see how likely it is that whatever we observe in the sample is reflecting something in the population. How we do that we'll go into in week 5, but that's the really fundamental process of inferential statistics. And the idea of probability, the idea of looking at chance or likelihood or the probability that something happens, is really fundamental to this process.